So, good afternoon, students, and we are back. And as a part of value-added course on stem cells, blood stem cells, and today Miss Neha Parihar ma'am will take basics of hematopoietic stem cell differentiation. So this will be very good lecture, and it will be very insightful. And over to you, ma'am. Thank you for joining with us.
Thank you, sir. Good afternoon, students.
Good afternoon, ma'am. Okay. Sorry for your inconvenience. Good morning. Good afternoon, students. Today's topic is basics of hematopoietic differentiation. As you already studied in your earlier sessions about the hematopoietic stem cell series, the hematopoietic stem cells are also known as the totipotential stem cells because these cells have the ability to self-renew and differentiate into the various blood cell lineages. So these cells also have the capable to extend its self-renewal, and they can also extend into the hematopoietic multipotent stem cells also. So the multipotent stem cells, also known as hematopoietic stem cells, they can extend into lymphoid series, myeloid series, and in the lymphoid series these cells can give rise to the lymphocytes, and the lymphocytes can also give rise to the B cells and T cells, and also the natural killer cells, as you earlier studied in your classes. So in this in this session, we will just going through the basics of the differentiation pathway. In this basics of differentiation pathway, you will know about as you all know, the hematopoietic stem cells has the ability to self-replicate itself, and it has the ability to give rise to the other cell lineages. So in these stem cells have these cells are the progenitor cells. Progenitor cells are those biological cells which have the ability to produce new types of cells. Now, in this series, you can see that there are some we can see in this picture we can say that there are some components, or we can say that there are some path in this pathway. We are having some terms. So in the starting of the session, I would let you know about these terms, like in interleukins and the cytokines. All of you aware about the cytokines and interleukins? Yes.
Yes. Are you aware about the cytokines and interleukins?
No, ma'am.
No. So cytokines are the proteins which helps in the formation or the proliferation of the immune cells or the different types of cells. Cytokines are the small proteins which can lead to the formation of those cells, and interleukins are formed of are the small cytokines. Okay, cytokines are the small proteins. We can say that it leads to the proliferation of the cells, and the interleukins are derived from those cytokines. And these GM-CSF, these are the granulocyte, monocyte, clonal stimulating factors. This helps in the proliferation of and the regulation of the stem cells. So in this we can know about how these interleukins, how these ligands, how these clonal stimulating factors are going to help in this pathway to form the new cell lineages. Okay, did you get me?
Yes, ma'am.
Okay, no, now PPT is visible in your screen.
Yes, ma'am.
Okay. Now the hematopoietic stem cells, it leads to the it forms the two common like it starts the two common lineages. One is common lymphoid progenitor cells and another one is common myeloid progenitor cells. Okay, now progenitor cells are the those cells which leads to the formation of a specific types of cells that might be lymphoid cells lead to B cells, natural killer cells, and T cells, whereas common myeloid progenitor cells lead to the formation of monocyte monocyte cells, macrophages, neutrophils, eosinophils, and the platelets and also the erythrocytes. Now, these interleukins are the linkages. These interleukin 7, interleukin 3, these are the linkages which are going to start the processes. Now when this interleukin 7, it gives enhances the, it expresses the stem cell proliferation, and it leads to the common starts the common lymphoid progenitor cell. When hematopoietic stem cell, when it is present in the bone marrow, so it this interleukin 7 leads to the starts the formation of common lymphoid progenitor cells. Then these common lymphoid progenitor cells are formed, and this interleukin 3, interleukin 4, interleukin 7s are going to work together to form the B cells. These interleukins, then B cells will be formed. Okay, then B cells again form the plasma cells, and plasma cells are going to form the antibodies. Same as interleukin 15, they have the they go interleukin 15s are going to enhance the growth and proliferation of the cells, and it is going to form the natural killer cells. Interleukin 2, all the interleukins are going to form the they are going to help in the cell proliferation. Now there is one term ligand. Ligands are the connectivity, they are the linkages between the these cells. So when they are going to form the dendritic cells are is the linkage between the myeloid series and the lymphoid series. This dendritic cells is the main linkage between the innate system and in the adaptive system. Now when in the myeloid progenitor cells, myeloid progenitor cells, what will happen, the granulocyte monocyte clonal stimulating factors, these are the some clonal stimulating factors which will give rise to the new types of cells. It is going to enhance the proliferation, and it is going to maintain the proliferation activity of the cells. So they are going to give rise to the progenitor cells. Now granulocyte macrophage progenitor cells when formed, this they are having some clonal stimulating factors which gives rise to monocyte and myeloblast. Monocytes is the series which happens in the agranulocytes, and myeloblast is the series which happens in the granulocytes. I think you all aware about the granulocyte series and agranulocyte series. Uh, Now the monocyte is going to give rise to the, now these are the different factors which are going to help to form the monocyte cells. Without the help of interleukin 14, granulocyte, monocyte, clonal stimulating factors, we are not able to form the monocyte. So these are the main components of this pathway. With the help of these components, we are able to form the new cells. new type of cells, which are the monocytes, and then it is going to form the macrophages. Now we are having the next series, that is myeloblast. In the myeloblast, with the same interleukins, with the same clonus stimulating factors, with the those are helpful for the proliferation and for the regulation of the cells. This, with the help of this component, neutrophils, eosinophils, and basophils are formed. Now there is one more series is here. How to Now the last one is the there are two more progenitor series. One is megakaryocyte and another one is erythrocyte. What will happen in megakaryocyte series? We are having TPO. All of you seen this TPO. This is the thromboplastin, and this is interleukin 3. These, both of these are going to help in the going to help in the formation of the new progenitor cells. Now these thromboplastins are going to form the progenitor cells. Now those progenitor cells, like megakaryocyte, with the presence of megakaryocytes, with the presence of thromboplastin and interleukin 6 and interleukin 7, 3, they give rise to megakaryocyte. Megakaryocyte are the polyploid nucleus. Polyploid nucleus, it means these nucleus are the capable of forming the 2 chromosomes. In the nucleus, 2 chromosomes are present, and with the help of interleukin 11 and thrombopoietin, platelets are present. These platelets are formed when the cytoplasms are going to degrade. Then these fragments of the platelets are formed. Now in the erythroid series, what will happen? There is a one enzyme or hormone, erythropoietin. This hormone is produced by the kidney. This hormone is going to give is helpful for the formation of erythrocytes. In the next series, in the next PPT. Now, in the interleukins, I have written about the interleukin 2. It helps in the activation of T cells. Interleukin 3, it helps in the proliferation of, like, all the interleukins are going for the proliferation and the growth for the each type of cells. So they are beneficial for the cell growth and proliferation. Now, specific differentiation pathway, like lymphosis, erythropoiesis, granulopoiesis, all the series we can study it over here, or we can learn in separately. As I know, you already learned about the lymphosis. You already learned about the lymphosis? Huh? Yes?
A little bit of introduction, ma'am.
Just I heard that you already gone through from the the types of the cells.
Yes, we went through the myeloid and the lymphoid cells.
Okay, so as in this picture, lymphosis series, there is 3 pathways start. First is adherence to the in this lymphoid series, hematopoietic stem cells, when the progenitor cells are formed with interleukin 7, it helps for the interleukin 7. It is going to give rise to it helps in the lymphoid progenitor. Now, lymphoid progenitor, with the help of interleukin 3 and interleukin 11, lymphoblast will form. When lymphoblast will form, then after that prolylymphocyte will form. When the prolylymphocyte series cells will be formed, then the differentiation will going on, and the natural killer cells and the small lymphocytes will form. After small lymphocyte, there is one more differentiation they underwent. Then B lymphocyte and T lymphocytes will be formed. Then another one is granulopoiesis. Granulopoiesis are also known as neutrophils. Poiesis means the formation of the excess number of the cells. So in the myeloblast cells will form. Okay. In the myeloblast, we are having these are the myeloblast cells will be formed, and then promyelocyte, then myelocyte, and then metamyelocyte, and then the neutrophils. So in megakaryocyte, the megakaryocyte are the erythroid progenitor. The progenitor cells are capable to form the particular type of the cells. So these megakaryocyte progenitor cells, they give rise to the proethoblasts with the help of the erythropoietin. When erythropoietin hormones acts on these erythroid series at the time of DNA synthesis, they give rise to the early erythroblast. Then it underwent another proliferation. It forms intermediate erythroblast, then late erythroblast. Then it formed the reticulocyte, in which no nucleus is present, and then in the last RBCs. Then in the last platelet megakaryopoiesis. In this megakaryopoiesis, thromboplastin hormone is going to act, and interleukin 15 is going to act. In this, hematopoietic stem cells, as all we know, is the self-renewable ability. So they are going to proliferate first into another different type of progenitor cells, that are myeloid cells and lymphoid series. Then after that, in the myeloid series, they underwent megakaryocyte erythroid progenitor, and with the help of CFU, cloning forming unit. Cloning forming unit, cloning forming unit is the capable. These cells are capable to originate the cloning forming units are the cells which underwent another proliferations, and then platelets will be formed. So cloning forming unit NK megakaryocytes are the capable cells which underwent proliferations, and then mature megakaryocytes will form, and then it leads to the formation of platelets. When the cytoplasm is going to degenerate, these platelet fragments will be formed. So this is all for today. Do you have any questions?
Yes,
No,
students.
ma'am.
All right. Okay. Fine, students. Ma'am, I would like to add a small note on your lecture. It was really interesting, ma'am, and this PPT looks really nice. And this is a very good lecture, ma'am. All I can say.
Okay.
I would like to add a few more points to your PPT. This was
Okay, sir.
yes, ma'am. To an extension of my morning lecture, I thought of discussing, and you made it clear, ma'am. I was really surprised. I was impressed by your work, actually. Very good. Yes, students, and I want to tell one more interesting thing about these stem cell students. See, what is the purpose of stem cells? Stem cells are differentiating into various types of cells. In case of this diagram, we can see that there is a hematopoietic stem cell, and this hematopoietic stem cell is converting to any one of the cell. It can be a white blood cell, platelet, or a red blood cell. Now listen, how this baby cell deciding to become a RBC, or a stem cell deciding to become a neutrophil. How is it possible? How the cell came to know, now I need to become a neutrophil? Who is guiding the cell to transform into one particular target cell? That is my question. How a stem cell taking a lineage of platelet, how a stem cell taking a lineage of monocyte? That is possible because of these cytokines. These, there are a cocktail of cytokines, and these cytokines will decide the cell to take one particular pathway. That is why cytokines are called as cell messaging molecules. Okay, cytokines are called as cell messaging molecules because they are guiding the cells to differentiate into a particular type of cell. So that is why we are using all these cytokines and their profiles. Understanding these cytokines will give us insights about the mechanism of the stem cell. So this is all about the cytokines, and ma'am did a fantastic task in this. Thank you so much, students. Any questions? Any more questions?
No, sir.
Yes, thank you so much, and we will extend this in the next week with other series of lectures. Thank you so much. Thank you so much, ma'am.
Thank
Yes,
you, sir.
I'm ending this.